Edit the videos too, so tell me when you've started.
I'm started.
Okay.
It's started. Go.
So I'm Austin Andreo, and on the camera right now is Azariah Arthur, and we're doing extra credit as a video, and our video will be on muscle contraction. And this right here is background first. So you start off with a ligand, and it goes through the plasma membrane, binds to the GCPR, which is the G protein coupled receptor, and then the conformation changes, and GTP binds to the alpha, and it causes the beta and the gamma to separate, activated, and then it activates the GTP, which the GTP interacts with the enzyme phospholipase C beta, which goes up to the PIP2, and it converts the PIP2 to either diacylglycerol, which is DAG, or IP3, and then IP3 goes into the ER sarcoplasmic reticulum, and then it releases calcium ions into the cytoplasm. Now going back up to the diacylglycerol, it goes into the protein kinase C, which phosphorylates the target myosin.
Go.
As Austin was saying, calcium that was released by the sarcoplasmic reticulum goes to bind to troponin and tropomyosin, causing them to shift over. Now the phosphorylated myosin 2, which is now active, can come and bind to the myosin, to the microfilament in the position that was made available or its binding site. This, once myosin 2 binds, it gives ATP a chance to bind to myosin and releases, and myosin is released from the microfilament. The myosin 2's head has an ATPase which hydrolyzes ATP to ADP and then inorganic phosphate. This causes a conformation change. Now, as inorganic phosphate is being released, myosin 2 can now rebind to the microfilament in a new position. And as ADP is now being released, this causes a pulse stroke of myosin 2 and a shift toward a positive direction.
Yeah.
Okay, so as ADP, as inorganic, ADP
shifts to the positive position.
As it shifts toward a positive direction, it basically causes skeletal muscle to contract. As us saying earlier in my earlier depiction, this is an idea of what myosin 2 looks like. This is the globular head, which contains the ATPase that hydrolyzes ATP to ADP, and this is the kinase, light chain kinase, which will be used in a later portion.
For non-muscle cell.
Go.
Oh, hello. So as I was saying over there, the whole thing with the skeletal muscle contraction, yeah, it happens in here, the sarcomere. So you go as actinin and myosin 2 works together. The myosin 2 binds and unbinds and then binds again, causes the H zone to go from big to small, which is muscle contraction, and then it actually relaxes again, and it goes back to big again. And this happens throughout the day as you're doing daily activities.
Go.
So you can see I drew this up in literally a second. And you might ask what happens in non-muscle cell contraction. So you have the calcium that came from the sarcoplasmic reticulum, and the calcium binds to the calmodulin, which causes a conformation change.
As Austin was saying, calmodulin with calcium binds to the myosin light chain kinase, causing the myosin light chain kinase to be active. Myosin light chain kinase then hydrolyzes ATP to ADP plus inorganic phosphate. In doing this, myosin light chain kinase can phosphorylate myosin 2, and then phosphorylated myosin 2 is now active for non-muscle cells. A contractile ring formed when a mitotic cell is going through cytokinesis also uses non-muscle contraction.
Go.
Another type of muscle contraction would be cardio-muscle contraction. Although we are not recovering this in the video because most of our information we got was actually from the internet, and even though the internet's always true, we didn't want to include it in the video but we are sending in through email that section of it. And I'm Andreo, and he's
And I'm Zariah Arthur.
and this is our short video on muscle contraction and non-muscle contraction. Thank you.
Da-na-na-na-na-na-na-na. 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 Dagger rates. Na-na-na-na-na.
Okay, we are not improving that. Wait, just stop. That's good. Dude, that's good. This is where it gets creepy.
All right, all right.
You gotta cut that part out.